New lithium battery technology is an integral part of effective scaling and efficient use of new and existing material handling equipment. In this presentation, you will learn how an integrated power platform enabled with the Internet of Things can increase the efficiency of your equipment and personnel while meeting targets for green initiatives. After a brief introduction to our company, I will discuss some power trends for the material handling industry, including how green initiatives are factoring into decision-making, as well as how achieving longer run times and decreasing maintenance time is influencing the direction of the technology used to power forklifts, pallet jacks, and other warehouse equipment. In the next section, Jeff will discuss how the latest technology for charging and fleet management using the Internet of Things, or IoT, can be used to increase utilization, efficiency, equipment uptime, etc., by taking full advantage of this new battery technology. Then I will discuss an example of how this is applied to a cold storage application and how return on investment can be realized and quantified for both capital and operating expenditures. Finally, we'll have some conclusions about what to look for in a battery solution and some time for question and answers. GreenCubes designs and manufactures rechargeable lithium battery solutions that are safe and accessible. Our solutions ease the migration away from lead acid, internal combustion engines, and other older technologies. Our vision is to design platforms to help accelerate the adoption of clean energy mediums. For over 30 years, GreenCubes technology has helped OEMs safely convert from lead-acid systems to the right lithium technologies for their operations. Among the many providers of lithium solutions, we stand apart for our precision-engineered conversions of hand tools, electric vehicles, hospital systems, and telecom towers. Our reputation and years in the business stand behind us to keep us innovating and driving ahead. We currently have more than 300 employees with worldwide locations and have designed over 100 power systems in the last decade. In addition to our power systems innovation, we are focused on utilization of remote monitoring and tracking to provide a solution not just across a system or site, but across entire organizations. Our worldwide business is focused in three main areas: industrial and medical power and automation, using standard platforms and custom designs, network power for telecom backup, and power platforms for material handling and other motive industries. In this segment, we have a wide variety of battery products, charging systems, and remote management capabilities. These technologies will be the focus of today's presentation. We offer more than 200 battery models for material handling equipment, including the smaller Class 3 electric motor hand or hand rider trucks, Class 2 electric narrow aisle trucks, and Class 1 electric motor rider trucks for indoor use. We have a variety of communication protocols, charger models, sizes, and harnesses for new models can be produced in about 12 weeks. In this introductory section of the presentation, I will discuss the state of power technology for material handling equipment and how they are adapting to address pain points with maintenance, increase runtime, and help organizations meet their green initiatives. There are two fundamental ways to power equipment: with a fuel-based system or an energy storage or battery system. Roughly half of the material handling equipment in use today uses propane or diesel-powered internal combustion engines. Although these engines have high maintenance costs and there are sustainability and pollution concerns, and certain industries cannot use them indoors, their overall market share is not expected to change substantially because the alternate green fuel cell is still in relative infancy and has reliability problems, requiring an almost 1-to-1 backup ratio. Nevertheless, we do expect them to eventually gain market share and form a complement to lithium-ion batteries, much in the same way lead acid and internal combustion engines have. The real shift in the market is in the stored energy power conversion from lead acid batteries to lithium-ion is on the cusp of a serious change in adoption. Lead acid is problematic. Although it has a low purchase price, it is only used for a single shift, requires regular water maintenance and monthly reporting, and it also has environmental issues, and workplace injuries are common. Lithium-ion, or in some cases we'll say lithium in this presentation, is viable for multi-shift applications, has much longer runtime, lower weight, smaller size, fast charging, and it's environmentally friendly. Likely, if you logged into this website, you are familiar with the challenges associated with lead acid batteries, which are low capacity, heavy, and large, including normal maintenance like watering and cleaning the acid residue typical of lead acid batteries, monitoring, which requires charger interface and takes 3 to 5 minutes per battery with a direct physical connection. Environmental and recycling issues require government reporting. Again, workplace injuries are very common, and it can include burns and joint injuries. They require 8 to 16 hours of charging and cooling time is required, which means that for every 24-hour period, there is 1 8-hour working shift and 2/3 downtime. The charging requires a battery room and a large footprint. I'm going to break down the advantages of lithium or lithium-ion into 2 sections. First, the low maintenance, which comes from the long runtime and cycle life, around 10,000. This advantage also comes from its charging tolerance, and later in the presentation, Jeff will talk about the best practices to take full advantage of these features and how the battery systems can be used to address specific pain points. Summary of features are a longer cycle life that enables a useful product life of up to 10 years. It accepts partial charges without degrading the battery life. It eliminates battery changes and maintenance and associated workplace injury. There's a long run time, which can be tailored to utilization. Faster charge times with opportunity charging. The charge time is about an hour, but what that really means is that you don't need a dedicated time for charging, and Jeff will discuss this later. The electronics required for safety and communication enable remote monitoring and troubleshooting. Also, there's better cold temperature performance, which we'll discuss in more detail in the example about 2/3 of the way through today's presentation. And then there's even the potential to reduce the number of trucks required overall at a facility. Now let's dedicate a minute to the environmental advantages of lithium-ion. First, lithium-ion is a fairly broad bucket of batteries types, but there are some different versions available for different applications. High capacity, lower power, long runtime batteries based on a cobalt cathode are often used in consumer electronics. Medium rate chemistry is used for applications like e-bikes. And we've selected a special subset of lithium-ion called lithium iron phosphate because it is well matched to the material handling industry. We sometimes use the acronym LFP for short. We chose this type of lithium-ion cell because it is the highest power, shortest charge time, and has the longest cycle life, making it well suited to the warehouse environment. For any lithium-ion, you would have a higher discharge and charge efficiency to reduce energy usage, better energy absorption, and charger efficiency, which lowers electrical cost. There's reduced water consumption overall and no hazardous spill precautions and procedures, and less material waste and scrap due to the increase in cycle life. There's a higher energy density and reuse for other applications. But also for LFP, it is non-toxic and non-contaminating and contains no rare metals. Iron is a readily abundant ore, so it doesn't need to be strip mined like cobalt. LFP chemistry is UL, CE, and RoHS approved. LFP is easy to dispose of due to no heavy metals. And finally, we take the reuse part of reduce, reuse, recycle seriously, and our batteries can have a second life, down to zero capacity for peak shaving and grid stabilization, solar and wind farm use, making this battery part of the green economy and green ecosystem. On this slide, we have a side-by-side summary of lead acid versus lithium. As I mentioned previously, the cycle life is more than 3,000 versus 500 to 1,000. The charging time is only about 1 hour versus 8. The charge efficiency is 20% better. The energy density enables smaller and lighter batteries by about 4 times. There is no detrimental effect to the cycle life with a partial charge. The voltage output is consistent across the discharge curve, enabling a greater depth of discharge and reducing wear and tear on the truck motor. Cold temperature is also better, and I'll be discussing that in detail later in the deck. Much of the advantage of lithium at the system level comes from its charging properties. There's a constant current phase and then a constant voltage or high state of charge phase, where the battery is basically fast charged and then topped off. For a lithium battery, this is mostly fast charge. Lead is only about 80%. The charging approaches 100% efficiency versus just 80 for lead acid, resulting in less charge energy loss and more savings. Finally, lead can have premature aging and loss of cycle life due to both reduced charge levels and over discharge. Even in a so-called deep discharge battery, the lithium ion is much more tolerant and forgiving, so you can use full rated capacity and realize the full cycle life promise. For all of these reasons, industry analysts confirm that lithium is the way of the future for the material handling industry. Motive batteries grew from 2.1 billion in 2019 to 2.6 billion by 2024, with a CAGR of just 4.6%. Motive lithium-ion batteries, on the other hand, had only 2.5% of the total motive market in 2019, but are experiencing a growth rate of 27%. We see internal combustion engines maintain their market share for the next 10 years, with just a small gain for fuel cells, but the green alternative, but an industry-wide shift from lead to lithium is happening today. E-commerce and productivity improvements are driving the demand for lithium batteries. And now I'm going to turn the presentation over to Jeff to talk about how to take advantage of this technology with the whole system solution.
Thanks, Robin. Yes, I'll discuss the utilization and efficiency of using lithium-ion and lead-acid batteries. So first, as we jump into using batteries in the material handling or motive power market, GreenCubes does acknowledge or recognize that there are issues with switching to lithium-ion batteries. And we are continually looking at making improvements in our products to address some of these issues on a go-forward basis. But first off, I want to address some of the issues with lead-acid batteries. First, one of the main issues with operators is acceptance and misuse of the equipment and the batteries. That is, getting them to plug in the batteries and getting them to properly water the batteries. And it's not just the operators. It's also the maintenance crew working with that equipment. There's also issues with long charge time, temperature stabilization, and stabilization times. In addition, one of the most critical issues is connectors. Connectors are definitely a major issue with today's power connection systems. Other issues include matching and having proper capacity. There's always an issue, especially as the battery starts to degrade over its life, and therefore having enough capacity to make sure that the operators can finish their shifts or finish their assigned work. Obviously, properly sizing the batteries to meet the application is critical. So one of the largest improvements with lithium-ion batteries is the efficiency of opportunity charging. Although opportunity charging is not new in this market, lithium-ion does definitely bring improvements. And one of the key improvements it brings is truly fast charging. Lithium-ion batteries can truly be charged in a 1-hour time frame. This allows the operators to have the mentality of just plug it in and quickly charge their trucks when they have some downtime, either on a short break or a long break. So in a short 15-minute break, you can add 25% of the charge back to the battery. So opportunity charging a lithium-ion battery definitely enables a 24/7 operation without having to do battery swaps. When an operator is on their break, using this time period can allow the battery to quickly go up by 25% or up to 100% if it's a 1-hour break. Again, this really enables a 24/7 operation, and it's a key benefit of lithium-ion batteries. One key note is that there's no degradation with overcharging or undercharging the batteries, because lithium-ion batteries are protected by a battery management system, and that is electronics that are embedded in the lithium-ion batteries. Operators can continuously plug in their batteries during the off periods, and they don't have to worry about the state of charge. And by doing that, the battery is kept at an optimal state of charge. That way, they can use the battery when they're done with their break, and they don't have to worry about having an overcharged battery. If there are some times when battery charging is forgotten, there may be little energy left in the battery at the end of the shift. And there's nothing worse than having a truck with a depleted battery handed off to you, and you can't use it for the shift. So you have to go through a long charge before you can start. At least with a lithium battery system, you can do a quick 15-minute charge or a short charge and give yourself plenty of energy to perform a couple hours worth of work. So opportunity charging is a key advantage enabled by lithium-ion. The other enabler that we brought to the market is what we call the multi-voltage battery. What this really does is it builds on opportunity charging and fast charging. Most equipment in the field today operates either on a 24, 36, or 48 volt range. There is equipment out there that does operate in the higher voltage range, say 80 volts, but again, the lion's share is in the 24 to 48 volt range. With a multi-voltage battery from Green Cubes, the battery is designed to discharge at the lower voltage required by the truck, say 36 volts. But the battery can accept charge at a higher voltage, say 72 volts. Essentially, we charge at twice the discharge voltage. What that does is allow twice the amount of power to be supplied into the battery over a single cable. Fast charging is available today, but it's done with dual cables. And most users recognize that a dual cable system is heavy and doubles the potential issues with connectors. Dual cable systems are hard to plug in, and the operators are against using those types of systems. So moving to a single cable system helps them make sure that it's always plugged in and charging. The multi-voltage battery advantages are presented in the image. Basically, your charge times are cut in half by doubling the voltage on the charger cable. Other than the battery configuration itself, the multi-voltage battery uses standard chargers and requires no changes to the truck. All the magic occurs in the battery. These days, 30 kilowatt chargers are very common and use a single cable. Another innovation that we have been testing in the field and will be releasing later this year is wireless charging. We're able to effectively charge at 30 kilowatts over a wireless system. This system has been tested and it truly operates at 30 kilowatts. We basically supported 600 amps of energy transfer. So our wireless charging enables fast charging. And this also helps with one of the most common issues that we all face, and that's connector damage and harness damage. So by removing these elements from the equation, it definitely helps with the efficiency improvements. We did have concerns about alignment and efficiency, and essentially the field trial demonstrated that the efficiency we achieved was 93%, which overall is a very high efficiency taking into account the charger and the battery itself. So from the wall to the battery, we achieved 93% efficiency. The Internet of Things allows the remote monitoring of batteries via Wi-Fi. This can be used to right-size your battery purchases for the optimization of CapEx expenditures, and real-time fleet management can reduce your OpEx expenditures as well. With a smart battery system, you're actually enabling the telemetry information from the smart battery system to be shared with the operators and the management team responsible for that fleet. So essentially, any type of lithium battery system from a small pallet jack to a large truck has the ability to provide its performance information up to our cloud-based management app so that reports can be generated and asset management can occur. Essentially, there's a wireless gateway on the premise that connects to the internet to provide the data. The battery management system is already collecting very detailed information about the usage and the health of the battery system, as well as reporting or logging any issues. So pushing that data out into the internet enables the operators, whether on-site or off-site, to better manage their operations. And it also helps with preventative maintenance. The IoT function embedded in our battery also enables Green Cube's tech support to remotely diagnose an issue without being on site. So they can provide the first level of tech support without ever being on the premises. Here are some screenshots of customers who have used our IoT capability. They will track charging behavior, and they can track overall energy savings as well. A key benefit, as you can see, is the issues that indicate that preventative maintenance must occur. This IoT function allows you to better manage your OpEx and CapEx expenses. When someone wants to examine their actual savings of their operating expenses, they can use this IoT capability to see the amount of energy they've consumed. These calculations show how much savings have occurred within each asset or the entire fleet, as well as the equipment utilization. So IoT is actually an enabler of better efficiency. There is obviously a higher cost initially when using or purchasing a lithium-ion battery, but as we will explain later in our ROI discussion, understanding the utilizations and efficiencies definitely helps offset those initial higher costs with lithium batteries. So really, IoT enables the optimization of the battery fleet. I'm going to pass the presentation back to Robin, who will cover some more examples and more specifically with cold storage applications.
I've prepared this example for you because it really showcases how to take advantage of everything that we've discussed so far. Medicine, food, and beverage require cold transportation as well as storage, and there's an increased strain on the cold storage industry as it adapts to increased fluctuations in response to online consumer habits, such as purchasing meal kits from services like HelloFresh. For cold storage, the insulated vehicle cargo area needs to be kept at a cold or freezing temperature. Cold temperature cycle life is vastly improved with a lower total cost of ownership with lithium-ion. First, let's look at the challenge of using lead acid in these applications. Electric material handling equipment is favored for indoor environments, but traditional lead acid batteries pose significant challenges, especially at extremely cold temperatures. The cold temperatures can cause the battery electrolyte to freeze, which lowers the usable capacity of the battery. As seen in the accompanying graph, which uses information commonly provided by lead acid battery manufacturers, the usable capacity as the temperature is lowered below freezing, between 0 and minus 25, it goes from about 70% to just over 40%, losing almost half the runtime of the battery. In addition, there is permanent damage to the battery, greatly shortening the battery's cycle life. In addition to normal maintenance, watering, and cleaning the acid residue typical of flooded lead acid batteries, traditionally, in order to operate the material handling equipment at such low temperature, the fleet is connected to an electrical grid at night, resulting in significant underutilization. Charge time for lead acid batteries is long, and time is required to equilibrate the temperature between extremes. If care is not taken, condensation can occur on the equipment, creating icy and dangerous conditions for workers. Unlike lead-acid cells, our lithium-ion battery packs offer a complete solution with integrated smart communication, charging, and heaters to keep the battery at optimal temperature. When the battery temperature is lowered, the intelligent control system enables the heaters to prevent the battery temperature from reaching a temperature too low to charge and prevent cell damage. There is no cold temperature capacity loss with integrated battery heaters. The charge system can be brought into the cold storage area so that the temperature equilibration is not required. 1 hour fast charging is enabled within the cold storage area, and charging can be performed opportunistically. The same equipment can be used for multiple shifts with no downtime. The power system makes it possible for forklifts and other material handling equipment to be used without interruption, so the number of vehicles required is lowered and operating costs are lessened. Forklifts will never leave the freezer, and pallet jacks can be charged in refrigerated trailers, so risk from condensation are minimized. And again, the cycle life enables a usable product life of up to 10 years. Let's take a look at how we can quantify these gains. First, there are capital expenditure improvements brought by the features of these systems and optimized during the design with the IoT interface. Everything from the batteries themselves to the charging rooms can be right-sized. You can eliminate battery handling rooms, ventilation accommodations, eye wash stations, and safety gear. You can reallocate battery handling rooms to become a staging area, additional pallet rack, or break room. And then there's the operating cost improvements. There's increased productivity and a lower total cost of operation by about 30%. 1 hour charge time eliminates the need for battery changes and equilibration charges. Lower electric utility costs for charging are reduced by about 20%. The lithium battery charging is about 98% efficient versus 80% efficiency with lead acid batteries. There's improved safety conditions for associates, eliminating battery changes and contact with the battery electrolyte due to the sealed maintenance-free batteries. There's improved environmental conditions, eliminating lead from your environmental footprint. There's improved asset utilization, 100% utilization with lithium batteries, or 1 battery per truck, versus up to 3 lead acid batteries per truck, which would be a 33% asset utilization. There's lower truck maintenance cost with uniform power delivery, extending the motor life and reducing motor maintenance. Presented here is an example of the ROI analysis that Green Cubes has performed with one of our customers. When we engage with a new customer, we can provide this ROI analysis to demonstrate the CapEx and OpEx advantages of adopting our lithium battery solutions. Then, after the customer has completed their trial or evaluation, we revise the ROI calculations based on their experience to confirm that our solution has delivered on the promised benefits. This example is for an 80 truck fleet based in the state of Florida. There are a few notable points that I want to bring to your attention. First, notice that the CapEx expenditure between a lead acid and a lithium ion is roughly the same over a 5-year period. The main difference is that the lithium ion solution has a higher upfront expenditure on battery assets, while the lead acid solution has expenditure of lead acid batteries spread out over the 5-year period. Notice that the annual maintenance cost for the propane and lead acid are roughly the same at around $600K per year, while those maintenance costs are negligible for the lithium-ion solution. Also notice that the fuel cost for propane is substantially higher than lead acid and lithium-ion batteries, but the lithium-ion batteries require less electrical energy for charging than the equivalent lead acid solution. The lower consumption of power is attributed to the higher efficiency of lithium-ion charging. The net benefit is that our lithium-ion solution provides a $2.8 million CapEx and OpEx savings over propane and about a $4.2 million savings over a lead acid solution. And for companies that have green initiatives underway, the propane and lead acid solutions generate an incremental 8 to 11 tons of CO2 emissions over the 5-year period. Now I'll pass it back to Jeff for the final part of the presentation.
Thanks, Robin. I'm going to wrap up with some real-world issues that we've seen in the field and how we at Green Cubes work to eliminate these issues. Leveraging our experience in the material handling and motive power market for the past 8 years, I'd like to share with you some of the common issues that we've seen in the field with lithium batteries, both our batteries as well as other manufacturers. The first issue is a poor voltage match between the lithium battery and the lead acid charger. This results in the battery not getting a full charge or not accepting any charge at all. Additionally, there are some lead acid chargers which have ripple current output, which can cause issues with the battery management system within the lithium battery. The other item that we have seen is poor fuel gauge calculations. While gauging the state of charge on a lead acid battery has always been an issue in the past, one benefit that lithium batteries do bring is an accurate fuel gauge. But if implemented improperly, you have the fuel gauge misrepresenting the state of charge of the lithium battery, which can lead to inadvertent shutdowns. Another issue which does occur in lithium batteries is imbalance of the cells due to improper interconnections between the cells within the battery. The bus bars interconnecting the cells is very important. Matching the cells from an impedance perspective is critical to ensure proper voltage across all the cells. The other characteristic with material handling market is the high levels of vibration and shock. So if the bus bars are not secured properly, this leads to damage to the cells, which over time leads to modest differences and issues within the lithium battery performance. The battery management system is a key part of the lithium battery as it properly maintains and balances cells over the life of the battery. The other issue is there's often ingress of foreign materials, and this can have a damaging impact on the electronics. We make sure that the battery management system is protected from such items as we use contactors that are sealed and our enclosures are designed to prevent material from ingressing into the battery systems. A lithium battery uses high-tech electronics and special electrochemistry technology. Although there are a lot of service companies and individuals out there who can work on lead acid batteries, the number of individuals qualified to work on lithium batteries is substantially less than those who can work on lead acid batteries. So at Green Cubes, we've definitely put a lot of focus on working on these issues. As Robin mentioned, Green Cubes uses lithium iron phosphate chemistry. The actual voltages of the cells and the cell connections within the batteries have been selected to essentially help match the lithium battery to lead acid batteries and lead acid battery chargers. We typically use a higher voltage, so there's less current draw for the truck, which also helps with the truck's motors and electronics. Lower current obviously helps with heat and is better for the truck. It is key to have clean wiring and routing within the battery, as there is a lot of electrical noise and EMC interference transmitted by the truck. So it's key to have wire routing as clean and short as possible. And as for environmental protection, we use conformal coating on all our electronics that are then sealed in a watertight enclosure. We also use steel enclosures for the battery case itself. These features are all critical to prevent issues in the field. Another item I mentioned is the bus bars. We spent a lot of time developing bus bars that allow for some flexibility to account for shock and to account for temperature differences as well. As Robin mentioned, using these batteries in cold storage is very common. The swelling of the cells is one of the leading causes of premature end of life of a cell. The battery design needs to mechanically secure the cell while allowing it to swell over the life of the battery. And with respect to fast charging, one of the benefits of lithium batteries is having high current charging systems. So the batteries, the cells, the electronics, and the high power wiring all has to be properly laid out for fast charging. At Green Cubes, we do focus on designing our products to support CapEx and OpEx savings. We've tried to optimize our batteries for those savings, such as the reduced consumption of electricity, as well as providing a focus on CapEx savings, such as giving back floor space to the customer by getting rid of battery maintenance rooms and battery handling equipment. We now have over 5,000 lithium systems deployed in the material handling market. As Robin mentioned, over the last few years, the adoption rate of lithium-ion batteries is really starting to increase. Green Cubes does work with the majority of the truck OEMs, and we have batteries for 80% of the key models in the market. And again, I want to emphasize our experience in the market for motive power systems, as we have over 20 years of developing lithium-ion battery systems. So to recap, I just want to provide a few quick highlights about Green Cubes. As I mentioned, our batteries cover 80% of the truck models in the marketplace. We have shipped over 5,000 batteries in the last 5 years. Our batteries are backwards compatible with existing trucks and chargers in the field. And we provide first, second, and third level technical support to our enterprise customers and distributors. So that concludes the presentation portion of our webcast. For the next few minutes, Robin and I will be able to take a few questions from the audience.